All right, Jeffrey Price here. I've got a little video for you. This is probably pretty short. We should get through it pretty quickly. I wanted to make sure that you understand exactly what's going on when you're setting angles and doing particularly segmented bowl angles is what we're going to focus on a little bit later. But all of the time when you're doing angles on your table saw, a few things for you to remember. So let's go over there to the shop. I've got a little demonstration for you, and we'll pick up over there. Head straight for the shop. Okay, I want to do a little test here. Going to test a digital angle measuring device. Okay, so I'm going to start here. Now make sure that my miter is on 0 right there. Make sure it's square. Sure enough, that's square. And then I'm going to put the gauge here on 30 degrees, right there. Hope you can see that okay, but that's 30 degrees. Now let's cut. Then I've got my digital gauge here. It's 0. Okay. 0 there, so let's see what we get. What? I got 60. I didn't get 30. I got 60. So what's going on there? That should be 30? No, that shouldn't be 30. It actually is, that's very correct. And in fact, if you don't believe that, let's just flip this over. Let's look at this little piece of wood we cut off of here. This is a nice little equilateral triangle, 60, 60, 60 degrees. What's going on here? Why is that? Why isn't 30 degrees like I put on my miter here? Well, let's go in my office and I'm gonna look at this a little bit with you and we'll make some drawings and stuff in there. So I've come back over here to the office and explain to you what we're looking at when we're over there working with angles on the table saw. So let me share this with you. Let's start with a couple of definitions. Let's recall that two angles that add to 90 degrees are called complementary angles. So here I've got an example, 60 degrees, 30 degrees, add to 90 or to a right angle, and those are called complementary. Two angles that add to 180 degrees are supplementary. So here I've got 150, I've got 30, that's 180 degrees. See, this is a straight line here. Those are supplementary angles here and here. Now, notice that 150, 30 more degrees. These are also supplementary, but notice that this 30 degrees, this 30 degrees, they're the same. That's what you get from across intersecting lines. The angles are the same. Now we'll see a spot where that happens when going through this. So let's consider a piece of wood that we cut square. Okay. We're going to have then, we assume here that this and this are parallel, that you've got a nice 2-inch board or something like that, who knows. And if you've cut it square, both of these are 90 degrees. Well, 90 and 90 is 180. So these are supplementary angles here. Well, that happens to be the case for any time you make a cut on a board that has parallel edges here. This and this are always supplementary. 60, 120 over on that side, right? Doesn't matter if you did 15 degrees, you would wind up with 15 degrees and 1 65 down here. So you would always wind up with supplementary angles. All right. Now, what do we do when we cut an angle? Well, out in the shop there, here's the table saw blade. I set the miter to 30 degrees, and I saw that what I got here was 60 degrees, right? And of course, that's 120 as we saw in the previous slide. Well, when you set the miter, here's the 0 point on the miter right here. So when you set 30 degrees, you set 30 degrees from 90 degrees. You don't set this angle. You set the angle from 90 degrees. Notice then the 60 degrees is the same as this 60 degrees here. And what that means is that this and this are complementary angles. All right, so you get complementary angles, not the actual angle up here when you use your miter that's zeroed at 90 degrees. All right, so that's something to always remember when you're doing angle cuts over there on your table saw. So let's see if we can apply this principle to an octagon for getting the segment angles that you would want to cut to get segments to make an octagon. So we'll start here. You see, if I've got an octagon, then from this edge to this edge, that's 360 over 8. That's 45 degrees. That's the angle that this sweeps out from the octagon. So now from there, I want to go over and go to a little different view and work more like a little bit of a lecture style. Okay, so let's go over there and show you how that's going to work. So let me go over here to this other view that I have so I can work with a pencil like I always have done for the last 40 years as an engineering professor. See what we got here. So look, we've already figured out this angle is 45 degrees for for an octagon. Okay, we'd like to figure out what's this and this. So we have then that a triangle now, the internal angles summed together of any triangle is 180 degrees. So, and these two angles are the same, right? That's isosceles triangle, if you remember that. But those two angles are the same. So we have 360 over 8, first of all, is that 45 degrees right there, huh? Now, then let's get these 2 degrees. Well, that's going to be 180 minus 45 divided by 2 because there are two angles here and here. And that gives me 67.5 degrees. So each one of these are 67.5 degrees. Okay, right there. Now, I want then, if I'm going to make a segment here, right, if I'm going to cut a segment, I want that to be 67 and a half and that to be 67 and a half. Well, what do I set the miter to then? Well, remember, complementary, right? So I'll set the miter to 90 minus 67 and a half, and that's equal to 22.5 degrees. So for an octagon, if I want to make an octagon out of segments, then the miter has to be set to 22 and a half degrees to get that angle. So let's see if we can do that in general then. So in general, we would have 360 degrees over in, that's this angle. Each segment will occupy 360 over in degrees. So if you have 10 segments, it'll be 36 degrees, or 100 segments, 3.6 degrees, whatever like that, okay? So let's kind of follow along over here. So then we'll have 180 minus 45 over 2, except I don't want 45 there. What do I want? A 45 would make it specific for an octagon. So I want 360 over n, and that is then the angle here, the general angle for these two. So then I want to make it complementary. So I have 90 minus 180 minus 360 over n divided by 2. And if I simplify that, 90 minus 180 and then 90, then minus a minus is plus. 2 into 360 is 180. So I wind up with the miter angle for the general case is 180 over n. May have seen that. If you do segmented stuff, you may have seen this. Well, now you know why. So I believe that that pretty well wraps up this video for me. And I hope that I hope you've enjoyed it. I hope you've learned something. That's the important thing is when we're doing these is that you learn something. And we'll hope to meet up with you again in the future. Come back.